Parallel resonant circuit. A parallel resonant circuit consists of an inductor L and capacitor C in parallel with each other to the circuit. Okay, so this is supplied to an applied alternating EMF by an AC source. Okay, so this is the inductor L, this is capacitance C. So we know that EMF of the circuit, AC circuit, is given by E naught sine of omega t. Let me give it number 1. Since in case of inductor the current is lagging behind the voltage by pi by 2, so we can write that IL is given by, this is E naught by XL into sine of omega t minus pi by 2. Give it number 2. This is sine of omega t minus pi by 2. And in case of capacitor, the current is leading the voltage by pi by 2. So this is E naught by XC into sine of omega t plus pi by 2. Give it number 3. Now the total current can be found out by adding 2 and 3. So total current I in the circuit, LC circuit, is given by IL plus IC. So this is E naught by XL sine of omega t minus pi by 2 plus E naught by XC. This is sine of omega t plus pi by 2. Okay, now this sine of omega t minus pi by 2 can be written as minus cos omega t, and this can be written as plus cos of omega t. So putting the value, E naught by XL, sine is minus cos of omega t, and this is plus E naught by XC, this is plus cos of omega t, right? So we have taken common E naught and cos of omega t. E naught cos of omega t taken common. This is minus 1 by XL plus 1 by XC. Okay, now putting the value of XL and XC, this is E naught cos of omega t. This is minus 1 by omega L. Okay, omega L plus, now 1 by XC is 1 upon omega c, so that will become omega c. This is the value of current. Now this value of current I will be 0 when 1 upon omega, when this factor is equal to 0. So we can write that I is equal to 0 when minus 1 by omega L plus omega c is equal to 0. Or we can say omega c is equal to 1 upon omega L, or we can say this is omega is equal to 1 by LC, 1 by root LC if we remove this omega square, and accordingly we can get nu as we have done earlier, 1 upon 2 pi root of LC. Now you can see that the current is minimum, and this frequency that we get is basically equal to the resonance frequency of the circuit. So we can say that at resonance frequency, at parallel resonance circuit, the current is minimum. So if we plot a graph between the current and frequency, we will get a graph like this. Graph will be like this. So at omega r, current is minimum. Okay, current is minimum, and this frequency that we have find out, nu L, this is nu is 1 upon pi root LC is known as resonance frequency. So if we have a recap, in case of series resonance circuit, at resonance current is maximum, and in case of parallel resonance the current is minimum at the resonance. So this is all about the parallel resonance circuit.